Good morning, Super Scholars. Today is Monday, November 30th. I hope you all had a wonderful break. You spent lots of time resting and enjoying time with your family. Our learning target for today is I am learning to add within 20. Your success criteria, I know I have it when I can make a 10 to help me find my sum. Let's start with our number talk. On the next slide, you will see some dots. It will only be on the screen for a few seconds, so try to remember how many dots you see. What did you see? How do you know that's how many dots you saw? Hmm, alrighty. If you saw 5 dots, give yourself a big pat on the back. I noticed that I saw 3 up here and 2 down here. And I know that 2 plus 3 equals 5. What about you? Did you see them the same way or did you see them differently? Now that I'm looking, I also see a group of 4 right here, a group of 4, and then 1. And 4 plus 1 equals 5. Good job, Super Scholar. Okay. Make sure you watch this video to practice counting to 120 with Grandma and Grandpa. Hmm, that Grandpa looks strangely familiar. I wonder who it could be. Don't forget to practice counting with them. Let's go over our vocabulary for today. Place value, the value of each digit in a number. So for example, number 43, the 4 has a value of 40 and the 3 has a value of 3. So we use the number 4 to represent 4 tens, which is the same as 40, and the number 3 to represent 3 ones, which when you put 3 ones together, that just equals 3. We're also going to be looking at the make 10 strategy. And the make 10 strategy is when you decompose or break down numbers to find a way to make 10. The reason we do this is because our brains love to work with easy numbers. Our brains love working with 5s and 10s. And sometimes when you see an equation like this, our brains don't love that. But if we decompose or break down this 7 into 4 and 3, then we can add this 6 and 4 together to make 10 and add whatever is left. So that's the make 10 strategy. We're also going to be looking and using base 10 blocks. So one little block by itself represents 1. 10 blocks, like this row lined up here, is 10. And if you count them, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This represents 10. And then the hundreds block has 100 little tiny blocks all together. And I won't count them all by one, but remember, one of these is 10, so you could count 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So what you are going to do next is you're going to click on juice boxes and number bonds, and it will ask you to make a copy. All you have to do is click this blue button, wait for it to load, and then it'll bring you to these activities. Okay, So, Julie brought in juice boxes for her classmates. They are packaged in two different ways. So, this is one way that they are packaged, and this is the other way. What do you notice about the packaging? What do you wonder about the packaging? I wonder why some of them are packaged in a group of 10 and why some of them are just packaged with only one. Hmm, I wonder what the purpose of that was. Look at the juice boxes below. How many packs of 10 did Julie bring? Is this a pack of 10? What about these? Are those packs of 10? No, because they are only one. This is a pack of 10. If we count them, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have one pack of 10 here, and then we have another pack of 10 here. So Julie brought two packs of 10. The next question asks, how many single boxes did she bring? So let's count our single boxes. Can you count those with me? 1, 2, 3, 4, 5, 6, 7. So she brought 7 single boxes. The last question asks, how many total juice boxes did she bring? You could solve this in a few different ways. You could go through and count all of the boxes individually, but that's a lot of work. So what we could do instead is think about our place value chart. So a place value chart, oops, and let me fix that for us, shows us hundreds, tens, and ones. And we know that Julie brought in 2 packs of 10. So I will put the 2 there because she brought in 2 packs of 10s, and that goes in my tens place. And she brought 7 individual ones. What number does that make? Right. Julie brought 27 juice boxes. Okay, are you ready for the next one? Let me clear my screen for us before we move on. Thank you for being so patient. Okay. All right, so we determined that Julie brought in 27 boxes of juice, and I'm going to put that right here. Our next task is to record this in a number bond. So what are each of these boxes going to represent? Well, think about it this way. When we counted how many she had, we broke it up into 2 parts. We broke it up into our tens, and then we broke it up into our ones. How many tens did we have? Right, we had 2 tens. But if I put the number 2 here, that's not going to be exactly right. So let's think. What does this 2 represent in my number? Does it represent 2 or does it represent 20? Think back to that number, that place value chart. Our 2 was in our tens, so it represents 20. Okay, so if I take my 20 out of 27, what's left over? How many single boxes did I have left? Right, I had 7. So I could break that down into 20 and 7 goes together to make 27. Great job, Super Scholar. Let's move on. Okay, so the next few parts ask you to think about how you can represent the numbers with a number bond. So you're going to use a number bond to represent the two different packages of juice boxes. And I'm sorry, I said that incorrectly. You're going to use base 10 blocks to represent the two different packages of juice. Okay, I think I went too far. Let me take us back. All right, so remember, we looked at 3 different examples of base 10 blocks. We had the one by itself, which represents 1, and we also had the tall one. And I'm sorry that's not perfect, but it'll do. Okay, that represents 10. So when we look at our different sets of juice boxes, which one do you think we would use to represent this package? Would it make sense to use our 10 base block to represent one juice box? No, probably not. So we would use 1, and then we have a pack of 10 juice boxes. Would we want to draw or use 10 little blocks, or would it be easier to use one full block of 10 that represents this? Right. We would be better off if we used one of the ones that represent 10. Okay. So next, on these next few slides, it is your task to come up with a way to represent the amount of juice boxes using base 10 blocks. So we have our 27 again. We used a number bond. We said you could break it into 20 and 7 to represent this number. And now it wants you to use base 10 blocks. How can we use base 10 blocks to represent 27? Well, let's think about our 7. Did we have anything that represented 7 blocks together? Not quite, but could we draw enough 1 blocks to equal 7? Yeah. So let's do that now. Do that with me and count. So I have 2, 3, 4, 5, 6, 7. All right. Then we still have our 20 left over. And as I'm looking at this 20, I'm wondering if we can break that down even more. When I look at it, I notice that I could do 10 and 10. And we have base 10 blocks that we can use to represent 10. So to represent 20, we could use 2 of these. And again, I apologize that my drawing isn't perfect, but that's okay. The most important part is to make sure that they have 10 blocks inside. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So now I have 20 represented here and 7 represented here. And together that makes 27. Good job, Super Scholar. All right. So today, we also want to make sure that you take the time to count backwards from 100. So we took some time to count forwards from 100, and now we're going to count backwards. And once you've taken the time to practice that, you're going to complete page 142 in your math workbook, and you are finding different ways to make the number 8.